Okay, good afternoon, class. So today we're looking at probability. At this point we have completed Venn diagrams, correct?
Yes.
So today we're looking at the three diagrams. Let's just check here. That is still three diagrams. That would be three diagrams. Okay, so combined events. You didn't look at this yet, no? Right. That's your heading for today, combined events, which will lead into three diagrams. Okay. This is for exercise 12.4. And this is on page, whoops, 12.4. This is on page 411. However, we're reading from examples on page 4. This is on which page? 406. We're reading from page 406. This is our reference. Okay. So combine dependent events. If the outcome of the first event does not influence the outcome of the second event, then the events are said to be independent. Okay, so examples of that would be, if I have a pack of cards, okay, and I draw a card out of that pack. However, I do not replace the card. That means to say my second card is dependent on whatever I draw in the first draw. Not so. So for argument's sake, if I have 52 cards in the deck, or in a pack of cards, 52 cards, and I draw an ace of spades, and I do the second draw, then I have one card less. Not so, which will affect my probability. However, if I put that card back in the deck before I do the second draw, then the first draw is, or the second draw is independent of the first draw. Does it make sense? So here we are told that if the outcome of the first event does not influence the outcome of the second event, then the event is said to be independent. That means to say the card is put back in our example. You guys understand? Right. In the next few examples, we will look at the combining the two events that are independent of each other. The one event is followed by another event, or the two events can take place simultaneously, but they are independent of each other. The one event does not influence the other. Events are independent if the probability of one event occurring does not alter the probability of the other event occurring, or the other event will occur. So we're looking at example 1, and example 1 is on page 407. Okay. So a die is one die, many dice. But we in South Africa say one dice, many dice. No? We say the same. Why? Because we're scared of the dead. Not so. We don't like the dead. Okay, so we don't like to talk about dead stuff in life. So a die is thrown and a coin is tossed. What? List all the possible outcomes. So, from the beginning, I'm going to start off with the tree diagram. Okay? Use one of three ways I can actually do it. I can do it without a table or no diagram. I can do it with a table. I could do it with a tree diagram. Okay? So what I'm going to do is, from the beginning, I'm going to go straight into tree diagrams. Okay? So, if a coin is tossed, a die is thrown. So what is the outcomes on the dice? 1 to 6, not so. So you go 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. What is the probability on each branch here? A 6, not so. So it's equally likely to land on any one of these numbers here. Not so. And this adds up to what, people? always add up to 1. Okay. So that's the first event. The second event is either heads or tails. So what is this probability on that for the first branch? 1 out of 2 and 1 out of 2. Not so. Heads or tails? 1 out of 2, 1 out of 2. You all agree with that? I'm going to draw it a bit bigger because I seem a bit crammed there. Pull this up a bit. Okay, so it's 1, 2, 4, 5, 6. As you see, that's 1 out of 6, 1 out of 6, 1 out of 6. And then all those branches adds up to 1. If I throw a 1 on the die, I can get a head or tails on the coin. Heads or tails. 1 out of 2, 1 out of 2. Heads, tails. Okay. So that's basically what happens. So what are my outcomes? Okay, my outcomes could be 1 heads or 1 tails. 2 heads, 2 tails. Can you see here? Heads, tails. It can be 2 heads or 2 tails. 3 heads or tails. 4 heads or tails. Can you see that, people? 5 heads or tails, 6 heads or tails. So how many outcomes are here? Oh, 6 heads, 6 tails. So how many outcomes are here? Yeah, 12 outcomes. Not so. So list up the probable outcomes, and this is what they're looking for. Okay. In B, we are told what is the probability of the combined event of obtaining, for obtaining a heads and getting a prime number. A heads and a prime number. Okay. So, for it to get the heads and a prime number, could it be the first one? No, the one is not prime. Can it be the second? Okay, so I'm just going to look where it's heads. Okay. Can it be 2 and heads? Yes. 3 and heads? 4 and heads? No. 5 and heads? 6 and heads? No. Why am I only going with heads? Because it says a prime number and heads. Although that is a prime number and tails, I'm not going to consider it. Because the condition is prime number and heads. Okay. So how many possible or favorable outcomes are there? 3. So the probability is the number of possible favorable outcomes over number of possible outcomes from the sample space. No? So we got 3 over 12, which is 1 over. You guys understand? See any confusion there? Alright, so let's go to the next question. Example 2. Example 2 is on page 400 and? No, this is still part of this. Sorry, C. See, we are told what's the probability for the combined event of obtaining a multiple of 3 and getting a tails. A multiple of 3 and getting a tails. So I'm going to pull this up here. So a multiple of 3 and getting a tails. Sorry. So what are multiples of 3? 3, 6. Okay? 9. Could I consider 9 here? There's no 9. And the tails. So it's going to be 3 and tails. That is 1. Not so. And then 6 and tails. Why are you not saying 6 and heads? Although it's a multiple of 3, it needed to be a tails at the same time. You guys understand? So how many outcomes are there? 2. So the probability will be 2 over 12, which is 1 over 6. Okay. Let's look at D. What's the probability of getting a head? Okay, so getting a heads. So how many heads are here? Is there any condition placed on the number? So I don't worry about the number. So how many heads are there? 1, 2, 3, 4, 5, 6 heads. So the probability will simply be 6 out of 12, which is 1 over 2. Okay. Will you guys understand? Is there any confusion? Let's look at the next example. Example is on page. Still the same. Okay. Some is long, no? Right. Pull this one reference up at least. Right, E. E says, what is the probability of getting a prime number? Where's the prime numbers? What are prime numbers? Numbers it only has 2 factors, 1 and inside. So which are prime numbers here? 2. That's also prime, not so. 3, 5. That's it. And that's the only condition here. What's the probability of getting it? So only condition is prime. So do I consider if it's tails or heads? No. Okay. So this probability would be 1, 2, 3, 4, 5, 6 over 12, which is okay. D, E, F. Calculate the probability of heads times the probability of a prime number. We've worked out the probability of a prime number, which is of the probability of heads was, I think it was C, no? Did C also to calculate D? The probability of getting a heads was D, which is also half. What's a half times half? A quarter. Not so. But we got a quarter somewhere else as well, didn't we? Where did we get the quarter? B. And what did we calculate here? What was the question in B? Prime number and heads. Here, what did they ask you to calculate? Prime number times heads. So what do you notice? It's the same. And here's an identity that comes into play here. Is that the probability of heads, or let's use general terms. The probability, let's use heads, times the probability of the prime number is equal to the probability of heads and the probability of prime number. You see that? So, these events, were they dependent or independent? It was independent of each other. So if I throw a 5 on the die, that doesn't affect the outcome on the coin. Not so. So they are independent. Not so. So this is for independent events. Okay. So what I'm going to do is I'm going to write it down in general terms. We're not always going to talk about the heads and the prime number. Not so. So in general terms, for independent events. It will come up, the explanation will come up again. For independent events, the probability of A times the probability of B is equal to the probability of A and B. This is what we call an identity. Later on, when they tell you events are independent, this must come immediately to mind. Okay? So probability, identity. One of the identities. Okay. I'm looking for my phone. Right. You guys understand? Right, let's carry on with our lives. Now finally we are in the next example. Not yet. G. Calculate the probability of a multiple of 3 times the probability of tails and compare it with B. Okay. What I'm going to do is I'm going to take this off here. So that we can pull this up a bit. Okay. Calculate the probability, so G. Calculate the probability of the multiple of 3. What the multiples of 3 are? 3 and 6. But we worked it out already, no? Which sum was that? C. No, that's combined. Okay. What is the multiple of 3? So is that one 3? 3H, 3T? 6H, 6T. Not so. So how many outcomes are there? 4 out of 12. Times the probability of tails. How many tails are there? 6 out of 12. Not so. Because it's 1, 2, I'm making probably the same markings already. 3, 4, 5, 6. There are 6 tails. 6 out of 12. And that is simply going to give us 6 out of 12 times 4 out of 12. Gives us 1 out of 6. So he asks you to compare it with C. And what was C's answer? Also 1 out of 6. But what did we calculate at C? We worked out the probability of a multiple of 3 and tails. Not so. So what we notice here? That the probability of the multiple of 3 times the probability of the tails is equal to the probability of the multiple of 3 intersection tails or and tails. So if that is equal, what do we know? The events are independent. You guys understand? Later on you'll see if that is not equal, then they're not independent. Okay? They will be dependent. You can either say not independent or dependent. Okay? Verstaan julle? Right. Yo, finally. Okay. I don't like so long example. But now I'm missing something. No. Example 2. So before that there was a note. Here we are told that in the example, the event of tossing a coin and throwing a die are clearly independent. Okay, as we said, the one is never dependent on the other. Okay, in this case. Getting a heads or tails from tossing a coin cannot alter the probability of the number obtained in the throw of a dice. The product, the rule for independent events, if A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. You all made that note already. Right. Right. Let's carry on. Example 2. Example 2, we are told that 2 coins are tossed together. two coins are tossed together. Determine the probability of each of the following cases. A. Throwing two heads. So firstly, if you're looking at our tree diagram, okay, you could draw a table or you could have done it without. Okay. I like a tree. Okay, so tree diagram. What are your outcomes when you first toss or when you first coin? Either going to be a heads or a. So what are my probability on the branches? Off and on. Okay. Then on the second coin, if I toss heads on the first coin, what would it be on the second coin? What are the outcomes? Heads or tails, which is off and off again. If I hit tails on the first coin, then what can it be on the second coin? Heads or tails, which is off and off. What are the outcomes? What could it be? Heads, heads. We do it systematically, okay? So heads, heads. Heads, tails. Tails, heads. Tails, tails. So let's answer this part of it. So the question says, throwing two heads. So the probability of throwing two heads is what? It's 1 out of 4. I can take it 1 out of 4 because they're even. They have equal chances here. Not so. Or we could have just said the probability of heads times the probability of heads. Should it be 1 out of 2 times 1 out of 2? Okay, you guys understand? Which is important, either way. So I was following those branches, that path. Okay. Let's look at B. Throwing a head and a tail in any order. So in other words, heads or tails and heads. You guys understand? So what would that be? 2 out of 4, which is off. Or you could have said the probability of heads and tails plus the probability of tails and heads. The probability of heads then tails will be half times half plus the probability of tails then heads. So it will be half times half. Okay, and then you put that in the calculator. So it's a half times half plus a half times half, which is the same thing. Wait, that's not the same thing. Times half. As you can see again, it's half. Okay. See any confusion? Okay. See another question linked to this? Yes, another 2. Pull this down. You probably just need a diagram. We'll take one of this off. Take that one off. Right. In C, we are told to calculate which. Okay, this takes one. You see, we are told calculate the probability of throwing at least one head. At least one head. So what are my options? It could be heads, not so? You say no. What does it say? At least. So it can be more. Not so. Heads plus heads tails plus tails heads. What's the probability of heads? Half times half plus half times half plus half times half. But we know this is a half already, not so? And half plus a quarter is 3/4. Okay. Or we can say is that, and that. 3 out of 4. You can do either or. Or we can apply the complementary rule, which is 1 minus the probability of no heads. Okay? Because that's the only one that's left out. Not so. We all feel so sometimes, no? Left out. So, you say 1 minus the left out ones. Will we be left with all the ones that are not left out? Can you see that? So if we add the people that's left out plus the people that's not left out, there will always be the total number. Not so. Likewise here, the heads are only heads are considered, and then we can just say 1 minus the probability of no heads occurring. Because if you look at it this way, if I go with a complementary event, then I say 1 minus the probability of tails, tails. What's the probability of tails, tails? So half times a half, which is a quarter, which is 3/4, which is that as well. You guys understand? So either or, we'll get the full mark. Okay. I can't really probability so easy, nah? You're thinking to yourselves, not a chance. People just look at D. D. Okay. D says, throwing no heads. Okay, we spoke about that now. No, no heads means to say, it's only tails. And how many only tails are there? It's only 1 out of 4. Or half times half, which is a quarter anyway. Okay, last question. E. What is the sum of, oh my word. What's the sum of C, which is 3/4, plus D? It is 1. And they asked you to explain. Why is it giving you 1? Because they are complementary events. They are complementary. That means to say if I add the two together, it gives you the total. Okay? In this case, the total was 1. Okay. Now moving too slow? Yes, okay, I'll pick it up a bit. I want you guys to get bored, nah? Alright, you're already bored, sorry. Alright, number 3. If there are 3 coins, if 3 coins are thrown, what is the probability of? So when we start, throw our pins off the table, yes, nice. Yeah. Start 3, yes. That's 3 done. So what are the, on the first coin, on the first toss, what are the outcomes? Heads, tails. So it's going to be 1 out of 2, 1 out of 2. Second, heads, tails, heads, tails. 1 out of 2, 1 out of 2. 1 out of 2, 1 out of 2. Thirdly, heads, tails. Which is also 1 out of 2, 1 out of 2, 1 out of 2, 1 out of 2, and so on. What are the outcomes? Let's list the outcomes. What do we have? Heads, heads, heads. Heads, heads, tails. Heads. Can't go heads, you are exhausted already. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. Not, she's saying there's a lot of tails. Is she right? No. A lot of everything. This is supposed to be the same number of each. Okay. Right, so how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Verstaan julle? Right. So the first question says, what's the probability of throwing 3 heads? Throwing 3 heads. So in other words, the probability is going to be that. Not so. Heads, heads, heads. So it's going to be probability of heads, heads, heads. It's going to give you a half times a half times a half, which is not a 6. What's wrong with you? It will be 1 over 8. Okay. You guys understand?
Yes.
Let's look at B. Throwing a heads and 2 tails in any order. So let's look. Heads and 2 tails, any order. So can I consider this one? This one? This one? This one? This one? This one? So it's basically 3 out of 8. Now let's say we didn't know that. Okay. So it could be the probability of heads, tails, tails. The probability of heads, tails, heads, tails. Plus the probability of tails, tails, heads. So heads, tails, tails. So it's 1 over 2 times 1 over 2 times 1 over 2 plus tails, heads, tails. 1 over 2 times 1 over 2 times 1 over 2 plus. You guys understand? And then tails, tails, heads. 1 over 2 times 1 over 2 times 1 over 2. So how many 1 over 2 times 1 over 2 times 1 over 2s are there?
3.
There are 3. So it's 1 over 2 times 1 over 2 times 1 over 2 times 3, which is 3 out of 8. But I showed you, you could have just added it up as well. Okay. But for now it's going to be easy to add this up. Why? Because they are independent events. So this probability is the same as that probability is the same. For now the weighting is the same. In our next lesson it's not going to be the same. That is why I'm explaining it to you over and over. Okay? I'm not going to stay easy, man. No? This part of your life is the easiest. No? So go to university. No? Then you must start working. No, we all wish when we're younger, now we're going to be rich. We're going to drive a Bentley and we're going to have a little lion cub. No? There's always a thing you wanted in life. I know you girls are a bit different. Huh? You're not worrying about the lions. Okay. But, yeah, it gets more difficult as time goes on. And we always think the time we are in is the worst. Okay. But don't let me rob you from those thoughts of yours, no? Right. People, let's look at C. Throwing at least 2 heads. So he's saying at least 2 heads. So, can this one be considered? Yes. Can this one be considered? Yes, yes, yes. So how many outcomes are there? 4. So the probability is now C would be heads, heads, heads plus heads, heads, tails plus tails, heads, heads plus heads, tails, heads. No? So that is 1 out of 2 times 1 out of 2 times 1 out of 2. And how many of them are there? 4. Which gives you, or I could have said 4 out of 8. Which is half. Okay. Alright, let's look at the next question pertaining this. Nothing. Okay. So people, you guys understand? Yes. So with us, you should be able to answer exercise 12.4. Okay. How much time do we have left?